Another ingredient that can play an important role to keep intestines healthy are organic acids. And they can play a role to weaken pathogens, they can cooperate with certain antimicrobials or boost the effect of antimicrobial substances. For instance, Attila Kovács of Biomin Animal Nutrition Company, he's a global product line manager, acids. He will explain all about it. Attila.
Thank you very much. Good day, ladies and gentlemen. Thank you very much for taking your time and joining this presentation session. We heard very good presentations so far today. And actually, I'm very keen on going further a little bit and trying not to complicate this topic regarding how the animals are performing, how the digestion is going, is rather just to bring an additional factor into this discussion. And what I will try to discuss with you today is how the organic acids are added, why they are added here, and also how to manipulate a little bit the composition of the diets. Because if I look at nutritionists, there is sometimes when they are very stressed because the space in the feed is somehow limited. It always has to adapt to 100%, right? They would like to have 110% because they want to add a little bit more vitamins. They want to include a little bit more premix. So there's always a question, is there a possibility to change these diets and also to play a little bit with these formulations? So if I show you briefly my talk today, we will go to discuss a little bit of why organic acids. And then, of course, if we mention why organic acids, we have to know how they actually work. And I've seen also that there are a couple of problems when speaking to customers, understanding what the organic acids are doing. Then boost the organic acids. This is how I call when we increase the effectivity of the acids. But I will go more deeper into this topic. Then replace acids in the diet. I think this is one of the topics which I will try to stress a little bit more, is how to make space in your diet. How to make the reduction of the acids in the formulations, but still don't replace all of them and have a good effect. And I will show you also some field experiences where we did some very good trials and very good experiments with some of the feed millers, but also some of the animal producers. So going at the beginning, why organic acids? Well, we heard today actually during this very good talks that we need to have a high level of productivity. Everybody's pushing to this. So if you go to your customer, the customer will say, well, we know exactly that this animal has this genetic potential, but can we do something a little bit there, something more to increase it somehow to decrease the FCR, somehow to have a little bit more growth. Then the high quality products. So what do we call high quality products? Right? We have to look into the feed formulations. We have to look into the components which come into the feed, which play an essential role. And I think this is the part where most of the money is invested. And I hope you agree with here, because feed is actually one of the biggest costs in animal production. Then bacterial challenge. And I will try to limit the discussion going into the direction of the gram-negative bacteria. And here in the section of the gram-negative bacteria, I think the most important ones are the E. coli or the salmonellas, which do play an essential role when it comes for losses of our customers in animal production. Then, looking at why organic acids. We heard during the talks that it is important to formulate right. So if you look into the feed of the animals, which could be basically one of the first contaminants with pathogens in the animal production, we know, and it's proven in literature, by adding organic acids into this diet, we basically acidify this diet. And what we do is not necessarily decrease the pH, but decrease the buffer capacity of the feed. And I think that most of the time this is the mistake that is done, because most of the people look necessarily at the pH. So I really want to decrease the pH because I know that we have to decrease this pH because it plays an essential role later. Well, the buffer capacity is actually very, very important. I think it plays a more essential role than the pH, but of course they go hand in hand because this is an interaction. Then if we go into the gastrointestinal tract of the animal, we reach the stomach. And this is a very, very essential point when it comes for the digestion. If we look into the stomach, what we want to achieve actually by adding the organic acids is the reduction of the pH. But the reduction of the pH comes then also from reducing the buffer capacity of the feed. So going a little bit further, we heard that it's important to have all these different protein sources and to have a good source. Well, it's not enough. You have to have a good source, yes, fully agree. But you also have to make sure that these proteins are also digested. And in the stomach, this is actually the first place where everything starts, because you have the pepsin, which is basically secreted as pepsinogen. Right? So to activate this pepsinogen, we have to make sure that the pH in the stomach is at the right level. Otherwise, we are going to end up with undigested protein that is going to migrate very nicely into the intestinal tract and create later on the problems. And most of the customers, they say, well, there is diarrhea in the piglets. Probably for sure it's a pathogen. Well, not necessarily. Because if you have the undigested proteins going into the intestinal tract, what's going to happen? The animal is actually trying to get rid of these proteins because it knows it's not good, right? Because if you have it undigested, maybe there's a pathogen that's going to feed on this. So getting rid of the undigested proteins will basically cause also the diarrhea. If you go with the acids into the intestinal tract later on, if you are able to bring your acids in the intestinal tract, let's call it like that, you basically can help to create a barrier. And this barrier is basically setting up a way that the pathogens will not cross from the intestinal tract into the other organs of the animals. And of course, going into the stimulation of the secretion of the digestive enzymes. So as we see, the topic is very large. And I will try to touch also a little bit the stomach pH and how this is important, because from my personal perspective, I think this is the most important part. As I told you, the reduction of the pH in the stomach is very important. If we look into the animal of the piglets, you see here on the y-axis, this is the pH, and here you see in the x-axis, you will have the weeks, so the age of the animals. So what's happening? We have the little piglet, which is born, then it starts to adapt its pH and trying to go down to the normal level. Normal level I call the pH 3 in this case. This is the pH where optimum activation of the pepsinogen into pepsine, this is where it happens the best. So as we see, the animal tries to bring the pH down to this normal level, but at this point here, there's something which happens, which brings down the pH very high. And this is the point where we go in and we basically wean the piglets. We heard it very nicely what's happening. We change from a milk diet into a solid diet. By this, the pH in the stomach will rocket to the sky, if, of course, we don't care. So what's going to happen? This is where the pepsin will not be present as pepsin. It will be present as pepsinogen, but not activated. And this is where the proteins are going to end up in the intestinal tract. So what we can do is focus at this point and help the animal to maintain its normal pH level in the stomach. Because enzyme secretion, and also later on, as I told you also, the barrier for the pathogens is going to start from here. I had also a couple of nice discussions with the customers, and usually when you talk to them about organic acids, the first reaction is, yes, of course, they decrease pH. Yes, thank you. I heard that many times. Yes, true. But there's also, I have the feeling, the untold story of this organic acids. Because organic acids, besides this pH decreasing efficacy, they also have the efficacy and the possibility of crossing and going into the inside of gram-negatives and giving there some really negative effects on these bacteria. So if we look a little bit more deeper here, and very briefly, we have the undissociated part of the acids, or the dissociated part of the acids. But basically, this is how the mode of action of organic acids is. But if you look into the undissociated way, and actually this is the only way that organic acids are able to cross membranes of gram-negatives. Here, when they go into the inside, so in the cytoplasm of this bacteria, they give all their negative effects by decreasing the pH, by also having the acid radicals which are working as toxic compounds. And if you look into the dissociated mode of action of organic acids, well, this is the best known one, as I told you. This is the one where the pH is decreased due to the hydrogen ion releases. And here we have basically an indirect effect, and the effect is actually a defect on the bacteria. Indirect effect is because here we just alter the pH of the environment. So what we do is we put the bacteria into environment where they doesn't really like it, right? And the direct effect is the effect where actually the acids are able to cross the membrane and give the negative effect. And if you look into here, actually, what are the main points in the inside of the bacteria? It's pH reduction, as I told you, but also the disruption of the different membranes, disruption also of the DNA and also the protein synthesis. So what we do here is actually we try to work on this bacteria from the inside out. But the problem is that on the market today, we have also different combinations. And yes, if you combine 2, 3, 4 acids together, there is always a synergistic effect. So we looked a little bit more deeper into this, and we basically did a trial where we combined a formic acid and the propionic acid together. We were looking at inhibition of E. coli and of Salmonella. And we've seen that, yes, with formic acid, there is kind of limited effect on this bacteria. Propionic acid had a little bit better effect, but when these two acids were combined together, then the inhibition effect was bigger. So basically the explanation is that if you have these two acids together, they work together. One is responsible of mainly decreasing pH, one is responsible of mainly crossing the membranes, and by this synergistic effect, they are able to have a much higher efficacy. So I told you that acids, they are able to cross the membrane. I mean, this is actually the distinctive part of this gram-negative bacteria. Because as you very nicely know, this gram-negative bacteria have the lipopolysaccharide layer on the outside. And this is actually the barrier and plays the barrier function, stopping the antimicrobial substances to cross and to go into the interior of the bacteria. So the question is, how can we increase the efficacy of different antimicrobial substances when it comes for gram-negative bacteria? And to explain here is, if you look into the literature, there have been several mentionings regarding permobilizing agents, regarding permobilizers. Actually, what they do is they go in and break up this membrane of the gram-negatives, and by this they facilitate the entry of the different antimicrobial substances. And antimicrobial substances are either added via the feed or water, but also the ones which are produced by the animal. So by this way, we help all the substances to work much better. And if you look into the trials, also, I'm sure that many of you heard about the VTT Institute. They are the ones which actually published a lot in terms of permobilizing effect of EDTA. If you look at a simple comparison, we see that EDTA has a good effect here on Salmonella, so on permobilizing the membrane of Salmonella, but not so good on E. coli. Problem is that, at least in the European Union, we have a ban for the EDTA in using animal nutrition. But if you look into the permobilizing complex, which was developed by Biomin, we see that this, even with a very, very low inclusion level, had a very high effectivity in breaking up the membranes of this gram-negative bacteria. So I told you so far that there's a combination of acids, and by combining, we have a synergistic effect. If we bring in then something to break up this membrane of gram-negatives, we enhance the efficacy even better. And there are also other choices in combining the organic acids, permobilizers, and also like phytochemical substances, for example, to increase later on the efficacy. And by this combinations, we are able to do replacement of single or combined acids in the feed. And what would be a general recommendation is to include or to replace conventional 2 kilograms of acids with 1 kilogram of the commercially available product. And we've seen actually, and I experienced some really, really high amounts of organic acids already in the feeds. I actually received last week a formulation with 18 kilograms of acids in the weaning piglets diet. Yes, this is very important to have acids because we need to acidify the stomach. But what's the point where it's actually too much? And this is where we can play. And this is where we can add this kind of products to decrease then the inclusion of acids, of organic acids, for example, and still have a good effectivity in performance, but looking into the decreasement of pathogens. And to look into the field experiences that we have done, we have chosen to two trials that I want to show you very briefly. First trial was with 102 wind piglets. We had 12 pens of 10 piglets each and 4 groups. And the groups were a negative control group, where we had no extra addition of acids. Then we had a group where we had a benzoic acid-based product, 5 kilograms per ton as a recommended dosage. Then we looked at the biotronic product, which we included with 2 kg per ton. And later on, we did the combination. So what we did basically, we replaced here 2 kilograms with 1 kilogram, and we decreased also 1 kilogram here. So what we did basically is we played a little bit with the acids inclusions. And as you see very nicely, there we go, body weight of the animals from the start, and when we look at here, you see that the animals were actually approximately 700 grams heavier at the weaning. And we know very good that at the weaning, it is very important that the animals have the highest weight possible, because this is going to play an essential role later on in the development of the animals and also in the earnings of the customers. Feed conversion ratio in these animals, we know very well benzoic acid plays a good role here, but when we did the replacement, you see also when we added the two products together, the efficacy here was very good also compared to control, but also compared to the single product. Then, if you look into a second exchange, here we had a formic acid salt-based product, which we replaced. So we had actually 6 kilograms, and then the same formulation, same diet. The only thing we changed, we took out this product. We added 1.5 kilograms of the biotronic product, and we looked again at the performance of the animals. What I have to tell you is that this basically came from a feed mill company who asked us to do these changes, but they said, okay, we do not want to see any change when it comes for the customers in the animals. And actually, this is what we achieved. So by replacing 6 kilogram of acids in the feed, we have also a little bit better performance, not statistically significant, but numerically it showed us that the animals were at least at the same level. And this is actually what the customer wanted. If you look into the FCR of the animals, we have here 3 points of improvement. And actually, what we really improved is for the feed miller, by replacing the acids in the diet, we made his feed cheaper. And this, I think, is a very important factor when we look at the competition on the market, also for the feed companies, but also when it comes of growing the cheapest animal with the best results. And if you come to the conclusions, I want to highlight again that a combination of different ingredients when it comes for acids or also different phytogenic plant extracts have a good effect when they are combined together. With the help of different agents to break up the membrane of gram-negative bacteria, we can actually boost the efficacy of the antimicrobial substances, and we are able to create more space in the diets, making the life of the nutritionists a little bit more easier, and also to see the satisfaction in terms of growth performance of the animals. And last but not least is trying to help everybody to gain more benefits. More benefits in terms of more earnings, to have healthier animals, and also to have a better production. And with this, I thank you very much for your attention, and I am very happy to take questions.
Thank you very much, Attila. A very clear presentation, I would say. Anybody from the audience having any questions? Yes, there is a question. Yeah.
Yeah. Thank you. Very nice talk. And I was wondering, in one of your slides, you have shown that the organic acid is able to inhibit the gram-negative bacteria. But how do you measure it? In one of the graphs I have shown with Salmonella and E. coli. Can you tell me about that?
Sure. So if I understood right, your question was, that you've seen that the organic acids are able to inhibit the growth of gram-negative bacteria, and how this was measured.
Yeah.
Good. So this was actually a trial that we have done in vitro in our labs, because we have our internal development, and in these labs we basically cultivated this bacteria, and we put into this environment later on the acids. But of course, you have to be careful in the inclusion levels. And what we did, we tried to correlate the amount of acids that we put into these plates to the amount of acids that we would bring into the diet. And by this, we were looking at the inhibition of the pathogenic bacteria.
Okay, thank you.
Anybody else? I do have some questions from the audience, so I'm not letting you go yet. Reducing the buffering capacity, what do you recommend in post-weaning diets?
Well, if we look into the diets of the young animals, we know very well that these are the diets which have the highest mineral and highest vitamin content. And these are actually the ones which are bringing the buffer capacity of the feeds up. If you ask me to give you a specific number here, I think it would be very difficult. And I would rather go back in not giving a specific number. It's rather to look into the formulations and look in the space that you can have or you can create and also help your animals to develop. And playing with the different inclusions of the acids, for example, can help you to bring your buffer capacity down.
Thank you. And one last question I have here. Could you explain a little bit about Biomin strategy for AGP replacement?
Well, the AGP replacement, this is an evergreen topic now, and we've seen actually that many countries already worldwide are focusing on this antibiotic reduction in the AGP replacement. I think I know in which direction this question goes, and if it's right, then people are looking for an alternative for the AGPs. Well, so far there is no silver bullet found for replacing an AGP. It's always to look into the solutions that you can bring to your customers in helping to reduce the AGPs in the diet. And of course, the first step would be to look at your problem. And most of the cases, we've seen that it's management, which plays an essential role also then with the knowledge in how your animals should be put in growing and bringing your benefits. So I think that this topic will and is further evaluated, and we put in significantly big efforts in trying to help the customers worldwide to decrease the AGPs in the diets.
Thank you very much.
Thank you.
Please help me to give a big round of applause for Attila. Thank you very much.
Thank you.